Assalamu alaikum guys. So I hope all of you are doing great. Today we are going to learn some topics in probability and statistics. Our two topics will be mean and variance. Mean and variance. So first let's come to our first topic, that is mean. So excuse me. What is mean? For example, if I write whole number integers from 0, 1, 2, 3, 4, and 5. So by calculating the mean of this data set means to calculate the middle number in this data sets. And how do we do that? We do that by adding them all up and dividing by the total number. So what we will do is we will add all of them up, and then we will divide by 1, 2, 3, 4, 5, 6. We will divide them by 6. So that will give us the mean of this data set. Now, what is variance? Variance tells you the dispersion of this data set, how much dispersed a data set is. So from its mean. So for example, its mean is right here, which is x bar. And now we want to know how much dispersed this data set is from the mean. So what we will do is we on the average. Remember, in statistics we always talk about average. So uh, we want to know how much dispersed this data set is. So what we do is we want to know how much of distance is 2 from its mean, 1 and 0, and then 3, 4, and 5. And then we square them, and then we divide it by n minus 1. So first let me write the formula for the mean. So what mean is the sum of all the numbers is divided by the total number of the numbers, uh, and variance is basically the tells you the dispersion of the data set by uh, when you subtract each individual sample point from its mean, and then you divide it by the total number of data points. Now let's discuss what is mean of a random variable. So when we talk in terms of a random variable, we uh, then we use the term expectation, which basically is the same thing as mean. So expectation is the same as mean of the random variable. Expectation is denoted by e of a random variable, which will be x, e of x. And how do you calculate the mean of a random variable or the expectation of the random variable? So the formula for that is you take each data point, you multiply it by its own probability. For example, x1, we have f of x1. Then you add the second data point, you multiply it by its own probability. That will give you some number. Then x3, f of x3, then up to so on xn, f of xn, like this. Excuse me. Now, to write it in a short form, we use this symbol, which is a summation symbol. We say n I equals 1, and we write x f of x. So that is the expectation of a discrete variable, or you can say that is the expectation of a random variable. That is the formula for the expectation of the random variable. Now what is variance? As I stated, variance tells you the dispersion of the data set. So what you do, for variance, and it is denoted by sigma square. This square thing, we'll talk about it a little later in this lecture. So what sigma square is, x, which is the individual data point, minus x bar, which is the mean, wholes, we square them up and then we divide by n minus 1. I will also explain why we use n minus 1 instead of n later in this lecture, so stay tuned. Alright, so this is the formula for, or you can say x1 plus, we do x2 minus x bar whole square by plus xn minus x bar whole square, and we divide them all up by n minus 1, or we can write it shortly as summation I equals 1 n, and we can say that xi minus x bar whole square is divided by n minus 1. So this is a short notation for variance. Now we'll also discuss what is standard deviation. Standard deviation. Standard deviation. So this I stated. Okay, so now let's come to the question: why do we use square with our variance? So okay, so for example, we have a line, and here we have its mean, which is sample mean, which can be this, and we have all of the numbers here, all of the data points here, here we have its mean here. Now when we will subtract each data point from its mean on the right side, and we do the same on the left side, and when we will add them all up, we will actually get 0. So to make these number positive, and to not in order to not get 0, we square the number, because squaring just makes a number positive. Now you guys must be thinking, why don't we use absolute? Because absolute does the same thing. You enter a negative integer, gives you a positive integer. There's a possible, and there's a good reason why we don't use absolute. So when we study statistics, we study excuse me. So when we study statistics, there are different levels of statistics, where we take cube, or we take to the power 4 to the power 5, just in order to get a larger number. Um, that makes it easy, that makes it a lot easier to study when we have a larger number in those larger larger levels. So that is why we square these numbers in order to get a larger number, rather than getting a smaller number. Now let's come to standard deviation. Standard deviation is nothing else, just the square root of this whole variance thing. So square root of sigma square will give you sigma, that will be equal to sum of n I equals 1 x minus xi minus x bar whole square divided by n minus 1 square the root. So this standard deviation is this. The formula for standard deviation is this one. So basically, standard deviation and variance both are the units of measurement of the distance of each sample point from its mean position. But standard deviation is more of a standard unit, and it's used more often because it's actually a little precise than variance, because when you take the square root, it will actually give you a more precise measurement of the distance than the variance. But you can use both. You can either use standard deviation and variance. Both are the units of measurement. Now let's come to the main question of our topic. Why do we use n minus 1? So actually what we have two types of means. If for example this is the number line, we have different types of data set. For example, we have this is a population, and we don't know uh, the whole population because the population is an infinite population. So what we do is we we don't know where the mean is because this is an infinite population. We will never know where the mean actually exists on this number line. But for example, we take a sample. We take this one, this, and this. Excuse me. Now we can actually calculate the mean, and we know where the sample mean is. For example, the mean is right here, x bar. And let's say that the population mean is right here. The whole infinite population mean is right here, because we use samples just to estimate the whole population. So this is the sample mean, which we can denote by mu. So when we will calculate the variance for this sample, for this, and this, and we will subtract each individual sample point from its mean, and we will get the variance. But if we do it like this, I equals 1 xi minus x bar whole square divided by n. If we do it like this, so we don't actually know where the population mean actually is. This this sample mean is only one possible position for the population mean to be on this number line, but we are just estimating um, the each distance of the sample point from its mean. So and also for example, if the population mean is here and we calculate the distance of this sample from here and this sample from here, it will actually be quite larger than if we calculate the distance from this sample mean. So that is why we divide by n minus 1 in order to get a smaller number. And when the denominator is small, we will actually get a larger variance answer, because the denominator is small. And when we divide by n, we will actually get a smaller number, because when a denominator is smaller, it will give you a larger answer, and when a denominator is larger, it will actually give you a smaller answer. So in order to get a little larger number, because there is a lot of chances of this population mean to not be in the same position as this sample mean. So population mean can be right here, here, we don't know. That is why we divide by n minus 1 in order to get a larger number. And uh, that was the reason why we use n minus 1. Thank you very much.